Hello everyone, welcome back to my YouTube channel. I'm Chandana, pursuing 4th semester in the Department of Electronics and Communication Engineering at Sri Venkateswara College of Engineering, Bangalore. I'm back with a new interesting subject, that is 8051 microcontroller, the subject code BEC405E, and today I'm going to discuss about the topic meaning and purpose of each status flag in PSW, that is program status word. Now let us see the contents. Introduction to microcontroller, meaning and purpose of each status flag in PSW, explanation of status flag in PSW, assembly level programs, future of microcontroller, and conclusion part. So before going to the actual topic, let us know about microcontroller so it builds strong foundation for our discussion. Microcontroller is small computer on single integrated circuit containing processor core, memory and programmable input-output peripherals. It is designed to execute specific tasks in embedded system, which systems are dedicated to specific function within large mechanical or electrical system. Microcontroller integrates a central processing unit, memory and input-output functionalities all condensed onto single integrated circuit. Microcontrollers are commonly used in various applications such as automotive systems, home appliances, medical devices, industrial automation, and consumer electronics. They offer a cost effective and efficient solution for controlling and monitoring tasks in embedded systems. Programming controllers typically involves writing code in high-level programming language, that is C or C++, using specialized development. The key components of microcontroller: CPU, the processing unit that executes instructions, and memory stores program instructions, that is ROM, and temporary data, that is RAM. Input output and allows communication with external devices like sensors, buttons, and displays. Program status word. PSW register, also referred as a flag register, and it is 8-bit register. So only 6 bits are used. So these four are carry, auxiliary carry, parity and overflow. So these are called conditional flags. So what is conditional flag? So they indicate some condition that resulted after an instruction of was executed. So as you can observe in the picture, the PSW3, this is PSW3 and the PSW4. So that is designed as RS0 and RS1. So that are used to change the bank. So the two unused bits are user definable. So this one PSW1 and this F0 PSW5, these are user definable and it is unused bits. PSW register of 8051. So the PSW register is 8-bit. As you can see in the picture, the CY is carry flag, that is PSW7, and PSW6 is auxiliary carry flag, and F0 is PSW5, that is available to the user for general purpose, and RS1 is PSW4, that is register bank selector bit 1, and RS0 is PSW3, that is register bank selector bit 0, and overflow, that is PSW2 overflow flag, and this is user definable bit, and P is parity flag, that is PSW0. So the parity flag, the set or cleared by hardware each instruction cycle to indicate an odd or even number of 1 bit in the accumulator. The CY is carried out from D7 bit, and the auxiliary carry flag, that is carry from D3 to D4. So coming on to the register bank, that is RS1, that is register bank selector bit 1 and register bank selector bit 0. So if this RS1 and RS0 both are 0, the register bank will change to 0 from the address of hexadecimal 00H to 0007H, and 012 the register bank will change to 1 and 08H to 0F7. So coming on to the overflow, the result of signed number is too large, causing the high order bit to overflow into the signed bit. And this parity flag reflect the number of ones in the register A. So this is what about the PSW register of 8051. So now we will go in detail about these flags in PSW. The first one is carry flag. The position of this carry flag is PSW7, and meaning of this carry flag is it indicates a carry out from the most significant bit during arithmetic operation. And purpose of carry flag, it is used to detect overflow in unsigned arithmetic operation and for multi-byte arithmetic operations. So auxiliary carry flag. So the bit position is PSW6, and the meaning of this is it indicates carry out from lower nibble bit 3 during arithmetic operation. And the purpose of auxiliary carry flag, it is useful in BCD, that is binary coded decimal arithmetic operation, to detect a carry from bit 3 to bit 4. So F0 flag, bit position is PSW5 and meaning general purpose user defined flag, and the purpose is can be used for the program for various application specific needs. And register bank select 1, that is RS1, and register bank select 0, that is RS0. The bit position is PSW4 for RS1 and PSW3 for RS0, and meaning selects the active working register bank, and the purpose allows switching between 4 register banks to facilitate different sets of working register. As you can see the values, RS1 is 0 and RS0 is also 0, that represents the bank 0, and RS1 is 0 and RS0 is 1, that represents bank 1, and if RS1 is 1 and RS0 is 0, that represents bank 2, and if both RS1 and 0 are 1 1, it represents bank 3. Overflow flag. So bit position is PSW2 and the meaning it indicates an arithmetic overflow in signed or arithmetic operation. The purpose is helps in detecting overflow errors in signed arithmetic operations. Parity flag. So bit position is PSW0 and meaning it indicates parity, odd or even, of the number of ones in the accumulator. Purpose used for error detection in communication and data storage. Zero flag, that is ZF, indicate that the execution of the last instruction. Instruction that affects flag bits. So these are all the instruction. CY represent carry flag and OV is overflow and AC is auxiliary carry flag, and X represents whether it may be a 0 or 1. So depending on the operation, so the X value may be 0 or 1. So add C, subtraction B, and multiplication and division, that will not affect, so that is 0, that is always a 0, and DA, RPC and PLC, set BC, that is 1, and clear C, so we will clear the carry, so it is 0, and complement C, so depending on the previous data, so the maybe the X value may be 0 or 1, and A and LC bit, that is AND operation, so that is also 0 or 1, and this is C ANDed with NOT gate, and OR operation, or that is handed with C, that is also a 0 or 1, so move C bit and compare jump it not equal to 0, and this is overflow is also the same thing, and the auxiliary carry flag. So now let us see the program related to this topic. So the flag bits affected by add instruction or carry flag, parity and auxiliary carry and overflow. Now let us see the example. So show the status of carry flag, auxiliary carry and parity flag after the addition of 38H and 2FH in the following instruction. So the move A, hash 38H, A represented as accumulator and add A, hash 2FH. So after the addition of this 38H and 2FH, we will get a 67H. So the 38 in the binary, we will represent it as 3 as 0011 and 8 as 100 and 2 as 0010 and F as 111. So after the addition, we will get as 011 00111. So the carry flag is 0 since there is no carry behind the D7 bit. So let me explain this. So this is 0 and this is 1 and 2 and this is 3 and this is 4 and this is 5, this is 6 and this is 7. So after the D7 bit there is no carry, so the carry flag is 0 and auxiliary carry is equal to 1 since there is a carry from D3 to D4. As you can see, this is the D3 and this is D4. From the lower nibble to higher nibble, so there is a carry transfer. So that is auxiliary carry is 1. So nibble is nothing but 4 bit and parity is 1. So as you can see 1, 2, 3, 4 and 5. So there is an odd number of ones here. So the parity flag is 1. Since the accumulator has odd number of ones, so it has 5 ones. So the parity flag is 1. So now let us see the another example. Show the status of carry flag and auxiliary carry and parity flag after the addition of 9CH and 64H in the following instruction. So move A ash 9CH and add A 64H. After the addition, the accumulator as 00H, so the carry flag will be 1. So let me explain this process. 9C, that is 9 in represented as in binary, that is 1001, and C as 1100, and 64 in the binary we will represent it as 6 as 0110 and 4 as 0100. So by the addition we will get 100. So in the binary form we will get 000 and 000. So carry flag is 1 here, because since there is a carry behind D7 bit, as you can see, this is 0, D0, 1, this is 2, this is 3 and 4, this is 5, 6 and 7. So behind the D7 bit there is a carry, so the carry flag will be 1, and auxiliary carry is equal to 1 because there is a carry from D3 to D4. As you can see, from the lower nibble to the higher nibble, so that there is a carry. So it is auxiliary carry will be 1. So nibble is nothing but 4 bit. The parity is equal to 0. Since the accumulator has even number of ones, so it has zeros of ones, so the parity flag will be 0. So this is all about the second example. Future of microcontrollers. So increased processing power and efficiency, and IoT integration, artificial intelligence and machine learning, low power and energy harvesting solutions, integration and miniaturization. So continued integration of multiple functions onto single chip. So it reduces the size and the cost of the devices. So the conclusion part. Program status word, that is PSW in 8051 microcontroller, plays a critical role in managing and indicating the status of various operations within CPU. Understanding each status flag and its purpose helps in writing efficient and error-free programs. The flags within PSW such as carry, auxiliary carry, overflow and parity along with register bank select bit provide essential control and status information that guides the flow of execution and arithmetic operation. Mastery of the PSW and its flags is fundamental for everyone working with 8051 microcontroller, enabling more effective troubleshooting, optimization and utilization of the microcontroller's capabilities. I hope you understand the concept of program status word. Thank you. Please do like, share and subscribe to my YouTube channel and stay tuned for more interesting videos like this. Thank you.